It used to be, how do you get data? Now it's all about, what do you do with all this data? So what we're trying to do to address this grand challenge in the face of all of these destabilizing factors in agriculture is to make agriculture more precise and more sustainable.
We can't simply double our acreage to produce this food. What we need to do is develop new crop production strategies based on the cloud and the ability to develop repositories for all this data, right? When we combine all this data, we can develop models.
We need maps of the in-field variation that's going on out there. To do that, we need a tremendous amount of data.
But trying to figure out how to consolidate it has been quite a challenge. Right now, we have to take and manually put the data into a program.
What we would like to build towards is a system that's cloud-based, to where we can bring this information from all of our locations back into a single cloud presence.
This pilot project with Microsoft has us evaluating some of their technology on our research farm. FarmBeats is providing us a mechanism for aggregation, data visualization, and analytics.
The only way we're able to do that is with machine learning and AI now. And we're able to generate those maps and recommend to growers how to alter their production on a piece-by-piece basis across that field. It's automated recommendations that growers can act on is the goal.
If you had that data in a set, then you could start to build scientific stuff into it and figure out what farmers have. Once you got a big enough pool of farmers that are putting their data in, turn it into a common language and then partition that out so that everyone can have their own silo.
The USDA is focused on meeting the 2050 Grand Challenge to feed and clothe a world population of 10 billion people. We need innovative solutions to increase agricultural production and decrease our environmental footprint. At USDA, our One USDA motto is, do right and feed everyone. The Agricultural Research Service is a key player in the 2050 Grand Challenge. We have 90+ research laboratories across the United States, about 2,000 scientists working on more than 600 in-house research projects. We define a data network as scientists working across projects on a specific research area. One of our key challenges is data management. With data being generated by government agencies, universities, private industry, nonprofit, individual farmers, how do we engage all of these groups to break down the data silos? If we can break down these barriers, we can more rapidly drive science forward, achieving our Grand Challenge goals before 2050. To help us do this, let me introduce AgCross, a hub designed to eliminate data silos. It provides our researchers an environment to share their data, their science, while engaging the American farmer. It maintains an individual project's identity while engaging other projects in what we call a network of networks. We have a network to study plant hardiness. The map on the screen here is a product from our plant hardiness network. AgCross is a new way to centralize our data and our science. It is a catalyst facilitating engagement. We envision all agricultural research projects being interconnected across the nation. AgCross is based on an innovative approach that we call the Vandenberg Principle. Here are Bruce Vandenberg and Jennifer Carter to tell us more.
The Vandenberg Principle is a standardized way to design tabs within AgCross. It consists of 6 or more tabs depending upon the study. The Overview tab tells a story about the site or collection. The Location tab explores the geographic representation of the site's field layout. The Methods tab tells us about the way measurements are collected and analyzed. The Visualization tab shows unique geographic representations of the data. The Analysis tab allows us to explore data in much more detail using tools. The Publication tab is a culmination of the study by presenting the scientist's publications. Links to the publication sources are provided here. This is a 6-step common framework that helps us standardize and improve scientific information gathered by the agricultural research community. Let's see how this really works with an example.
Of course, my topic is manure, but manure is great. In the Manure Shed project, we are assisting our farmers and ranchers with sustainable and environmental practices. Each project has configurable tabs and layers of data to enhance visualization. On the Phosphorus tab, visualization is more than just a single map. It's the ability to query, filter, and download data, saving our scientists valuable time. And now Bruce is going to tell us more about gas.
The Organic Amendments experiment in Fort Collins, Colorado is focused on both the monitoring of greenhouse gases, which is called GraceNet, and nutrients in the soil, which is called NuoNet. This experiment has been ongoing since 2012. As soon as they show up. The bright green plots have treatments applied to them each growing season. This experiment allows us to explore ways to minimize environmental impact by reducing greenhouse gas emissions and nutrients in the soil. These relationships can be found in an Advanced Analysis tab using Insights. Here we see a nitrous oxide value is out of limits. What's even more interesting is that our next tab allows us to quality control and edit the items. After checking the scientist's handwritten notes and calculations, one of the entry values was several orders of magnitude off. So we click on the graph, go to the list, and it brings up the survey in Survey 123. We find the value, edit it, submit the survey, go back to the list, and then look at the graph again. We have corrected the data entry error. The last example shows the true power of AgCross. It provides the ability to connect multiple networks for given scientific measures. What looks like a simple graph is really not that simple. This graph of average nitrous oxide is an example of scientists integrating data across 30 different networks. For the first time, our researchers can rapidly discover, organize, and filter data, enabling them to spend more time on science.
And that is one of our goals, to decrease the time that our scientists are spending on data management so that they can spend more time on fundamental research. One of our scientists, Stephen Mirsky, is here to tell us a little bit about how he engages the American farmer in what we call the on-farm network.
Farming is knowledge intensive. Therefore, we need to understand how climate, soil, topography, and agricultural management interact spatially. We do this by reimagining the farm landscape as a living laboratory. And AgCross is the type of cyber infrastructure scientists like me need to achieve such goals. However, when we bring our science onto farms, we do need our protocols to be sufficiently light and tight. This is due to limited infrastructure and the increased labor costs. IoT systems are perfect for on-farm research. We can collect massive amounts of information about soil, water, and plant dynamics on farm with low-cost technologies. In our national network of 150 farms and rapidly growing, we use tablets with web-based apps, both to standardize the collection of farm management history data, as well as our protocols across a distributed network of scientists. Now let's look at some of the IoT systems that we're using. Here you can see we're using sensors with low-cost, real-time data acquisition systems for monitoring soil moisture and temperature. We can also mount two tractors, multispectral sensors with LiDAR in order to quantify the spatial distribution of plant quality and quantity. Last, you see our phenocams. We call them stress cams because we can collect a ton of images around a crop while it's growing, apply machine learning to those images, and quantify when it's undergoing water stress. In all of these IoT systems, we often need a lot of training data to inform our machine learning. So in this approach, you see us using machine vision and learning to detect and identify weeds from crops. We build low-cost, low-tech solutions because we have that distributed network of scientists with various different technical skill levels and capacity. We connect to these inexpensive frames a QR code. That way, when we're ingesting these images into our statistical package, we can automate assigning identifiers to the image and do continuous machine learning. In all of this work, it requires that real-time data acquisition, aggregation, analytics, and visualization software. That's why we're collaborating with technology companies like Esri and Microsoft to build out that cyber infrastructure and the data hubs necessary, as well as the connectivity in rural America to permit edge computing, a critical component of IoT systems. When we put this all together, we build an information ecology for precision sustainable agriculture. It lets us link up our science to the data. We build insights from that data in the form of decision support tools. Those tools are informing our growers while we're actively monitoring what the farmers are doing. That data feeds back into AgCross, which further informs the tools and creates the kind of positive feedback loops necessary to feed the world in a more precise and sustainable way.
One of our progressive research leaders, Dan Roberts, is working on implementing data management systems to improve the efficiencies of day-to-day research activities.
From the perspective of a research leader, AgCross provides the means to decrease data touches by the scientists, increasing efficiency, increasing the amount of time the scientists have to work on this problem, this grand challenge, if you will, of producing more food while at the same time decreasing the impact of the food production system on the environment. And this is important because the year 2050 is not that far off when you consider we need to develop new technology and then transfer this technology to the farm community. What we've been talking about here this morning is how ARS is using WebGIS in this platform, AgCross, to break down these data silos that exist amongst scientists scattered throughout the United States, and importantly, to engage the farmer. Leveraging our resources, enhancing opportunities for collaboration and synergism, speeding the development of this technology. As we go forward, it is absolutely imperative that the scientists and the policymakers work together to serve the American farmer so that the American farmer in turn can feed and clothe the world. On behalf of my colleagues on stage today in the USDA, thank you.
Thank you, Dan. Thank you, Jeff. It's great. Thank you. This is amazing, isn't it? As I've sometimes described, we're moving into an era where virtually everything that moves and changes will be measured and made available, in this case, made available to farmers, a kind of distributed use of government's data, true democracy. This is a beautiful thing.